day everyone. In this video, we will tackle quantitative research design. Quantitative research design focuses on numerical data, structured analysis, and measurable evidence, and it provides a foundation for understanding the relationships between variables, testing hypotheses, and offering evidence-based explanations for political behavior, public opinion, and policy outcomes. Quantitative designs reflect positivist assumptions that guide how variables are examined. The approach relies on determinism, where relationships among variables are central to answering research questions and hypotheses. It also relies on reducing ideas into measurable, controllable variables, obtaining objective data from observation, and using instruments that demonstrate validity and reliability. These assumptions serve as the foundation for both survey and experimental research. Now, we'll move into the first major topic, the definitions of survey and experiment. A survey design, or the non-experimental design, provides a numeric description of trends, patterns, attitudes, or opinions by studying a sample of a population. For that sample, the researcher generalizes patterns to the entire population. An experimental design, meanwhile, focuses on testing the impact of treatment on an outcome. Although experiments may also involve samples and generalization, their defining feature is control, especially the control achieved through random assignment to treatment and control groups. When one group receives an intervention and the other does not, the researcher attempts to isolate whether the treatment produced the observed outcome. Next is we'll go through the components of the survey method plan. Surveys typically follow a standard structure that appears in journal articles and research proposals. The first component is the survey design explanation. This includes the stating of the purpose of using a survey, which is to generalize result from a sample to a population, and explaining why survey is the most appropriate method. Some advantages include its efficiency, relatively low cost, quick data collection, and ability to capture attributes of large populations. It's also necessary to clarify whether the study uses a cross-sectional survey where data are collected at one point in time, or a longitudinal survey where data are collected over an extended period of time. Additionally, the researcher must identify the form of data collection, which can include self-administered questionnaires, interviews, structured record reviews, structured observations, or online web-based surveys. No matter the format, justification should be based on cost, convenience, data availability, and strength and weaknesses of the method. After the design explanation comes the discussion of the population and sample. This section identifies the population, its size if known, and how individuals will be accessed. It must also explain whether the sampling design is single-stage or multi-stage. Single-stage sampling is possible when the researcher has access to a list of all individuals in the population. Multi-stage or cluster sampling is used when no complete list exists. The researcher selects cluster first, then samples within them. The sampling section must also describe whether probability sampling or non-probability sampling is used. Probability sampling, such as simple random sampling, gives each member an equal chance of being selected and supports generalization. Non-probability sampling, like convenience sampling, is easier but weaker in terms of representativeness. If the researcher uses stratification, this also needs to be explained, including which characteristics are used and how proportions are maintained. The sample size must also be stated and justified, often using formulas found in survey methodology texts. This section introduces the actual survey instrument, describing whether it is newly created, modified, or adapted from an existing source. If it is adapted or combined from different instruments, the necessary permissions should be obtained. In the case of online surveys, Platforms such as SurveyMonkey or Google Forms may be used, and the proposal should mention their capabilities. Instrumentation also requires discussing the instrument's validity and reliability. Validity includes content validity, which asks whether items measure their intended content, criterion, related validity, which examines predictive or concurrent correlations, and construct validity, which focuses on whether items measure an underlying theoretical construct. Reliability examines consistency, including internal consistency and test-retest stability. If items or scales are modified, previous validity and reliability may not hold, so these need to be reestablished during analysis. The instrumentation section also typically includes sample items, descriptions of scale types, such as Likert scales, and covers pilot testing. A pilot test helps refine questions, format, and scales, and the proposal should explain how many people will test the instrument and how their feedback will be incorporated. For mailed surveys, multi-step administration procedures are recommended to increase response rates, including advance notification letters, survey mail-outs, reminder postcards, and follow-up questionnaires. Following instrumentation is a section on variables in the study. Although variables appear earlier in research questions and hypotheses, the methods chapter must show clearly how variables connect to items on the survey. This is usually done using a table that cross-references variables, research questions, or hypotheses, and specific survey items. This structure ensures clarity in how constructs are measured. The next major section for survey is data analysis and interpretation. This involves several steps. First, the researcher must report how many respondents returned the survey and how many did not, often using a table. Second, the researcher checks response bias, which examines whether non-respondents would have answered differently. These techniques include wave analysis and respondent-non-respondent comparisons. Third, descriptive statistics such as means, standard deviations, and ranges are reported for all variables. Fourth, if the instrument includes scales, the researcher should explain how items will be combined, perhaps using factor analysis. Reliability, again often through Cronbach's alpha, should be checked for scales. Fifth, the researcher must identify inferential statistical tests appropriate for the research questions or hypothesis. The choice depends on the number of variables, how they are measured, and whether their distributions are normal. Common tests include correlations, t-tests, analysis of variance, and regression techniques. Finally, results are presented in tables or figures and then interpreted relative to the hypothesis and broader meaning. After establishing the survey method components, the chapter moves to the experimental method plan. Experimental method sections typically include participants, materials, procedures, and measures. To begin, the section on participants describes how individuals are selected either randomly or through convenience sampling, and how they are assigned to groups. If individuals are randomly assigned, the design is considered a true experiment. If intact groups are used without random assignment, the design is quasi-experimental. The methodology section should also explain procedures for matching participants or using covariates to control extraneous variables. The sample size should be determined using power analysis, which considers alpha level, desired power, and expected effect size. Next is the variables in the experiment. The independent variable include at least one treatment variable and possibly additional measured variables. Dependent variables represent the outcomes measured before and after the treatment. These need to be clearly identified. Instrumentation and materials come next. This includes describing the instruments used to measure outcomes, their validity, reliability, and the permission needed to use them. It also includes describing the materials used in the treatment, such as instructional materials, scripts, or programs. Pilot testing of materials may be included to ensure they can be implemented consistently. Next is the experimental procedures. Researchers identify the type of experimental design: pre-experimental, quasi-experimental, true experimental, or single-subject design, and illustrate the design using the Campbell and Stanley notation system. This notation includes symbols such as X for treatment, O for observation, R for random assignment, and horizontal lines to indicate non-equivalent groups. The, the chapter provides example of one-shot case studies, one group pre-test post-test designs, static group comparisons, alternative treatment designs, non-equivalent control group designs, interrupted time series designs, classical pre-test post-test control group designs, post-test only designs, the Solomon 4 group design, and ABA single subject designs. After describing the design, the chapter discusses threats to the validity. Internal validity threats include history, maturation, regression, selection, mortality, diffusion, compensatory rivalry, resentful demoralization, testing effects, and instrumentation changes. For each threat, the chapter offers ways researchers can address the issue, such as using random assignment, comparing dropouts to continuing participants, separating groups, and maintaining consistent instruments. External validity threats relate to generalizing results to other people, settings, or times. This includes interactions of selections and treatment, setting and treatment, and history and treatment. Researchers should address this by restricting claims appropriately or replicating the study. There are also threats to statistical conclusion validity, involving low power or violated assumptions, and construct validity, involving inadequate definitions and measures. The procedures section outlines the step-by-step process of conducting an experiment, such as administering pre-test, assigning participants, implementing treatments, administering post-tests, and comparing groups statistically. The data analysis section identifies descriptive and inferential statistical tests appropriate for experiments, including t-test, ANOVA, ANCOVA, MANOVA, and non-parametric tests when assumptions are violated. Single subject designs rely on graphs to show changes over time. Finally, interpreting results involves checking whether hypotheses were supported, considering the influence of the treatment, reflecting on literature and theory, evaluating potential validity threats, and identifying implications for practice and future research. Overall, the quantitative research design, whether survey or experimental, requires a clear explanation of the design, sampling, instrumentation, variables, procedures, analysis, validity issues, and interpretation. Each component must be connected logically to the research questions and supported with methodological reasoning.